Hi students, today we will start the elimination reactions. Before this, in this chapter, we have discussed the substitution reactions in detail, that is nucleophilic substitution reactions of SN1 and SN2, the mechanism of these reactions, the condition of these reactions, and the products, expected products of these reactions. So today, we'll start from elimination reaction. In this topic, elimination reaction, we will be studying the introduction to the elimination reaction, that what are the elimination reactions, types of elimination reactions, that how many types of elimination reactions are and why, or on what basis this has been divided into different types. Then the mechanism, what is the probable mechanism of each type of elimination reaction, and orientation of double bond, that where will be the double bond and on what principles the double bond will form between two carbons, and reactivity, that what is the rate of these reactions and on what conditions, like solvents, like the base, or like the substrate, on what conditions it depends, that what will be the reactivity and what will be the rate of the reactions. Dear students, as you know that there exist many types of organic reactions, like that is reduction, oxidation, hydrogenation, hydrolysis, and free radical reactions, and so there are a lot of types, but there are three basic types of organic reactions. One is the addition reaction. In addition reaction, a group of molecule is added to a substrate, that is organic substrate, and at the end that organic substrate must be unsaturated one. It means that there must be at least one double or triple bond present in that organic substrate for the addition to occur. So at the end, we get a saturated compound, and then there are also conditions that what will be the product, what should be the product of that substituted compound, the reactivity and stereochemistry. The second type is the substitution reaction. In substitution reaction, one group, one moiety, or one functional group is replaced by another functional group or another moiety. This substitution occur according to certain rules, as we have discussed previously in the substitution nucleophilic reactions, SN1 and SN2 reaction. The third type is the elimination reaction. What is the elimination reaction? It's a class of organic chemical reaction in which a pair of atoms or group of atoms are removed from a molecule, usually through the action of acids, bases, or metals, and in some cases by heating to a high temperature. The removal is in the presence of some catalyst, that may be acid, base, metal, or maybe high temperature. What is basically the elimination reaction, or what it do? Basically, elimination reaction, it is used for the transformation of saturated compounds, that is organic compounds, to unsaturated compounds, double or triple bonds. Or we can say that it is a principal process by which saturated compounds, organic compounds, are transformed to unsaturated organic compounds. Elimination reactions are distinguished by the kind of atoms or group of atoms that leave the molecule. There are two types of distinguishing. One is to name some reaction on the basic criteria, and the other one is that to distinguish it on the basis of the molecule that leave the substrate. Never mind what will be the kinetics of that removal. So, on these conditions, it is distinguished on the basis of the kind of atoms, or group of atoms that leave the molecule. And due to this, there are two main methods involved in this type of reaction. That is dehydration, means the removal of water, or dehydrohalogenation, that is the removal of a halogen and hydrogen from the substrate. Okay, on the basis of kinetics, the elimination reactions are classified as E1 or E2. The In E1 reaction, the reaction rate is proportional to the concentration of the substance to be transformed. So the E1 reaction, the kinetics are there is one substance involved in the rate determining step, and that is the substrate, or the substance which is to be transformed to the eliminated product. While in E2 reaction, the reaction rate is proportional to the concentration of both the substrate and the eliminating reagent. That may be acid, base, or that may be metal, or anything which is responsible for the elimination of the group from the substrate, that is also involved in the rate determining step. Okay, the elimination reactions are also denoted by another term, that is beta elimination. Why it is called beta elimination? Because normally in the elimination reaction, the proton which leave the substrate, or which is removed from the substrate, is from the beta carbon. Beta carbon is that carbon which is near to the, or adjacent to the carbon from which the reagent or halogen has been removed. Okay. On the removal of a halogen and the proton, a pi bond is formed and a leaving group is removed from the substrate. But there are also some alpha elimination reactions that occur that occur by alpha elimination route, or they occur that the two groups are removed from the same carbon. Like for example, alpha elimination is that reaction in which the two groups are eliminated from the same carbon. If we look into this example, the chloroform, it has undergone the elimination reaction in the presence of a strong base. The hydrogen and chlorine are removed from the same carbon, and at the end we get a carbene. This is the product. But this species, the carbene, is very much reactive and hardly exist in independent conditions, so it will undergo further reactions. Beta eliminations are the reaction in which the groups on adjacent atoms are eliminated with the formation of multiple bonds. Look into the example. It's a hydrogen halide. This is a alkyl halide. Alkyl halide, and from this a hydrogen halide has been removed in the presence of a base. This is the alpha carbon to which the halide is attached, and this is the beta carbon from which an hydrogen is to be eliminated. So the removal of this halogen from the alpha carbon and this hydrogen from the beta carbon creates a double bond between two carbons, and we get an alkene. And this reaction or this mechanism is beta elimination reactions. The beta elimination proceeds through two mechanisms. On the mechanistic pathways or on the kinetic ways, the elimination reactions can be divided into two categories. That is E2 mechanism or E2, that is bimolecular elimination reaction, and E1, unimolecular elimination reaction. As we have previously discussed in the substitution reactions, nucleophilic substitution reactions, the E2 and E1 mechanism differ in the timing of bond cleavage and bond formation, and it's similar to the SN2 and SN1 mechanism. Thank you very much for your patience.